Okay, we're presented this problem where Rover is tied to the corner of a square pen. Now, when I read math problems, whenever I see square, I immediately remind myself that all these sides are going to be the same. Because here they tell you that it measures 10 by 10 feet. Sometimes they just give you one side, which is 10, and you have to just remember that if it's a square, they are all 10. His leash is 14 feet long, so this distance is going to be 14. Determine the exact number of square feet outside the pen that Rover has to roam. So the first thing I think of with this problem is a circle with a center right here that has a radius of 14. So I envision this dog going around the square building. Now, he can't go completely around because when this leash butts up against the corner of the building, he's going to be restricted. So the answer to this problem is not a circle with a radius of 14, like so. Rather, you have to consider this leash being inhibited by the corner of this building. So I went ahead and depicted that in this drawing. Again, if Rover was free to roam completely around, he would have a 14-foot circle of area, but he's not. What happens is that when he heads counterclockwise, the leash butts up against the building, and the 14 feet of the leash is taken with 10 feet along the building and another 4 feet, as so. So if we go to the iPad here, we're going to be dealing with all of this area plus the area that you're going to see with these small quarter circles as he goes around each corner if he's traveling clockwise or counterclockwise. Okay, so let's first do the big area. So this is going to be represented by 3/4 pi r squared. Again, because this area is going to be 3/4 of a circle with a radius of 14. So our radius is going to be 14 feet. So we're going to have 3/4 pi times 14 squared. Now, I happen to know what 14 squared is. I know off the top of my head it's 196. The reason is that I've encouraged my SAT students to memorize all the squares from 10 to 20 because you see these a lot on the SAT. So 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196. And I remember that the 13 and 14 are just reverse the last two digits. 15 squared is 225, 16 squared is 256, 17 squared 289, 18 squared 324, and 19 squared 361, 20 squared is 400. So I encourage you, anyone watching this video who's going to be taking their SATs, to memorize all the perfect squares from 10 to 20. Now, in this situation, I am not going to expand that to 196. The reason is I know that I have a 4 in this denominator that I'm going to be canceling out. So not only do I not expand the 14 squared to 96, but I say to myself, I'm going to break these 14s down twice into 2 times 7, because again, I know 4 is in the denominator. Now I'm going to be able to cancel out that 4 and those two 2's. So now I'm dealing with 7 times 7 times 3. So that's going to be 49 times 3. Now, if you want to learn how to do this type of problem in your head, what you do is you take the 3, you multiply it by 40, because 4 is in the tens digit. So in your mind, you say 120, and then you multiply 3 times 9, which is 27, and you'll get 147. If you don't want to do that in your head, then you can just do long division, assuming you do not have a calculator and available to you, and you get 147. Okay, so coming back up here, the answer to the area of this big 3/4 circle is going to be 147 pi feet squared. Okay, and remember, when you're dealing with area, you're always dealing with square units. 147 pi feet squared. And the square is with the units. It's not, for example, 147 pi squared feet. That is incorrect. Make sure you get the square with the units. And the reason the square is with the units is because when we did our original calculation, pi r squared, or actually this was 3/4 pi r squared, but when you have pi r squared, the radius is 14 feet times 14 feet. So you have two units here, each with the exponent of 1. So if you rewrite this as 14 times 14 times feet to the first times feet to the second, to the first, feet to the first times feet to the first becomes feet to the second. Just like x to the first times x to the first becomes x to the second. So again, in summary, this square goes with the unit, not with the pi. Okay, let's move down to the smaller portion of the total area, and that's going to involve these 2 quarter circles down below. So basically, you have 2 quarter circles with a radius of 4. Because, as mentioned, once the leash clears the wall of the building, there's going to be 4 feet left. And that's going to be its own individual circle, 1/4 of which the dog can roam. So we have here, this is going to be 1/4 pi r squared, which is going to be 1/4 pi 4 times 4. Again, I am not going to expand that knowing that I'm going to come along and cancel that out. So this is going to be 4 pi for the orange quarter circle. We'll get the same exact result with the green quarter circle. So that's going to be 8 pi feet squared. And our total, when we add them up, 147 pi feet squared for the large 3/4 circle plus 8 pi feet squared for the 2 quarter circles, and our final answer is going to be 155 pi feet squared for the amount of area that the dog can